Alright, today we have topic 6.2, rectangles. In this lesson, we will look at a rectangle as a term, we will define it, we will also look at the properties of a rectangle and use those properties in solving equations and problems related to rectangles. Alright, so let's go ahead and continue on with our first page of notes. We have the term rectangle. The definition is a parallelogram. Remember everything from our previous lesson that we learned about our parallelograms? They will come into play with a rectangle. But the difference is a rectangle is a parallelogram with 4 right angles. So if we're going to draw one of these to the best of our abilities, here's our sketch. And the key note is it has 4 right angles. So, pretty quick, pretty simple. There's a sketch, there's a rectangle. Alright, reading on. Because a rectangle is a special type of parallelogram, it has all of the properties of a parallelogram. However, the diagonals of a rectangle have an additional special relationship. Alright, let me move on down here. Let's have a look at this. Alright, it tells us to name the diagonals. So if I was going to come over here and I was going to pick a point, there's a diagonal, as well as right there. So name them. We have OM and LN. Alright, find the lengths of these diagonals. Now, what we're going to be looking at is our distance formula. Alright, so let's look here at OM to begin with. Let's look and find our point O. Point O is at -6, 3. And point M, which is our second point, is 4, 4. Alright, so our distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I'll go ahead and put this in here. D equals our square root, and I'm going to go ahead, I'm going to fill this out. The square root of x2, which I will let this will represent my x2, y2, and this will be x1, y1. So we have parentheses 4 minus, now x1, which is a -6, all of this squared, plus 4 minus 3. And this is right here. Let's see, 6. This is actually a -3, so it is a minus. Let's see, I'm going to erase this. That way we can rewrite here, because it is minus a -3. Close the parentheses and squared. Go ahead and continue that on out. Alright. So D equals, go ahead and start my square root side. Or do our math right here. We're going to change the signs. 4 plus 6 is 10 squared plus 4. We're going to change the signs. We're subtracting a negative, so that is 7 squared. I'm going to go ahead and continue on. D equals, okay, this is the best looking 10. Let's help it out right there. 10 squared is 100. So the square root of 100 plus 7 squared is 49. So the square root of 149. Now we're not worried too much about digging in a little bit deeper. I don't think you're going to find the perfect square root of that. So now it's got over here for us to find LN. Alright, so point L. Let's see, L is at -6, 4. -6, comma 4. And N, if we find our point N, is going to be a 4, excuse me, 4, -3. 4, -3. All right, so let's go ahead and put this into our distance formula. I'm going to grab another color. Let's keep this separated here. D equals square root, and let's let this be x2, y2, x1, y1. A little cramped here for space, but we can make it work. x2, 4 minus x1, -6, close parentheses, squared, plus, all right, y2, which is a -3, minus, and y1, a 4 squared. Continue that on. All right, so D equals 4 minus a -6. That looks familiar. And so that's going to be a 10 squared. Let's start this. We've got 10 squared plus, we have here a -3 minus 4, two negatives, subtracting it. So we're going to add the 2 and keep the sign. So you're going to add the 2. It's going to be a 7. Keep the sign, which will be a -7 squared. Let's go ahead and keep these in parentheses right here. That's going to help us out. It's going to make it look a little bit better here. Because now 10 squared is 100 plus -7 squared, and which is, we've seen this, 49. D equals that. Okay, let's add these two together to see what we get. D equals square root of 149. So, what do we notice? If we're going to compare the two, they are the same. Make sure we write that down and we know that. The lengths of their diagonals are the same. So, here we go. Thus, we can say that if a parallelogram is a rectangle, if the parallelogram is a rectangle, then its diagonals are congruent. Congruent. We grab a color here to write congruent. Didn't really want green, but we'll go with green. Alright. So we know that the diagonals of a rectangle are congruent. Let's go through here. We've got our figure. And let's fill out all of our properties. Alright, let's grab a color here. Opposite sides. I'm going to just put a mark out here. This will be my orange. Opposite sides are parallel. So here, here, and this is an opposite side of here. Okay. Opposite sides are parallel. Check. Opposite sides are congruent. Put me a little white dot to help us see. So this is congruent here. The same with here and here. Alright. Let's see. What else do we know? Another color here. Opposite angles are congruent. So opposite angles are congruent here and here. This is just, if you remember, this is the definition of a parallelogram. We have yet to get to anything that's special about a rectangle. Everything that we're doing so far is the exact definition of a parallelogram. Alright. Consecutive angles are supplementary. So we can go and we can say these two angles right here will equal 180. Make sure I get that the very edge of the screen there, perhaps. Alright. The diagonals bisect each other. But there's something special that we're going to look at with these two. If our diagonals are congruent and they bisect each other, I'm not going to come over here and put 1, 2, 3, 1, 2, 3, which is just like before. If you remember on the last one, we came over here and we 1, 2, 3, 4, and then we matched it here. We don't have to worry about 4 because if our diagonals are congruent and they bisect each other, we can take that one away. And we can put these, and we can say every one of these segments are congruent. So you have 4 segments on the inside that are congruent. Our two bisectors, our two diagonals, excuse me, they bisect one another. They create 4 congruent segments. And let's look at here for lastly that we have 4 right angles. There's a right angle. I'll draw these big to go around our congruent opposite angles. So there we have an image that we can refer back to for all of our examples that will show us what is congruent, what is parallel, what is equal to one another. Now, the thing with this also, in which, let me remove that. If we look at this, we have 4 right angles. So not only are our opposite angles, let's go up here and let me snag another color here that I haven't used yet. Test this one out. So not only is this true, we can take these two together and we can say, trying to find a good way, here we go. We're going to make this really thick. Put it that way. That all of these, even better yet, we don't need that. We can just do this. They don't need to be 1. All, if there's 4 right angles, every one of these equal 90 degrees. Therefore, every angle is congruent. Now, what's going to fall, what you're going to learn, is going to be the same thing that is true with our interior angles. We will have right here will be congruent, whereas this opposite side, say they're supposed to put 3 lines, and then you'll have 3 lines here because they are opposite side, but they are the interior. So they are alternating interior angles. See if I can remove that line a little bit. All right. Let's take this information now and let's move to our second page of notes. And let's look at some examples. Example 1, quadrilateral MNOP is a rectangle. It tells us MO. Alright, so it's telling us this entire thing here, MO, is 2x minus 8. And NP, which is, let's go ahead and grab this. And we'll go with green. 23. It asks us to find the value of x. Now, what we know about the diagonals, they are congruent. If they're congruent, that means they're equal. That means MO equals NP. MO, 2x minus 8 equals NP, 23. Alright, so add 8. 2x equals 31. Divide by 2, we will be left with x equals 15.5. That is our final answer. Alright. Example 2. Quadrilateral J, K, LM is a rectangle. Alright, so we know a lot of stuff already. It's a rectangle. It tells us a lot with our properties. LP is 3x plus 7. MK, this whole MK, this whole thing here, maybe somewhere. Let's grab this color. It grabs green again. Well, y'all gonna have to live with green. 26, MK is 26. Find the value of X. Now we gotta think a little bit deeper. We know that LJ is equal to 26. But what do we know about what we have here? What about PJ? What does PJ equal? We know that PJ is also a 3x plus 7 because these are congruent. So they're the same thing. So I have two of them now. I can come over here and you can either add them both together. You can say I've got a 3x plus 7 plus a 3x plus 7, or you can go ahead and make a little bit of shortcut and you can say 2 times 3x plus 7, because there's two of them. So 2 times 3x plus 7 is equal to 26, because we know that it equals MK. They are congruent. So you have a 6x plus a 14, same thing you would get if you added them together, equals a 26, subtract 14, 6x equals, what do you know, 12. Divide by 6, divide by 6. We have an x equals 2. Find the value of x. So we are good. Moving on, example 3, quadrilateral. ABCD is a rectangle. It just told us a lot from that. If it just says it's a parallelogram, or if it does not tell us that it's a rectangle, this that we just did does not hold true. If it does not state that this is a rectangle, right here it says it is a rectangle. Now we know that these are congruent. If it just says it's a quadrilateral, and if it just says it's a parallelogram, that tells us nothing in terms of what the diagonals say. We don't know that they're equal. What we do know is that AP equals PC and that DP equals PB, but we don't know that AC is equal to DB unless it's specifically stated. Alright, AC, it tells us our AC, our entire AC. Let's see if I can grab a different color other than green right here. AC, 4x minus 13. DP, what do you know? It's going to throw a little tricky one in here for us. DP equals x plus 7. We know that AC equals DB. We know half of DP, or our DB, which is our DP. B and P sounds a lot alike, but we know half of it. Half of it is an x plus 7. So how would we find the entire portion of it? Just like what we did before. If we want to find the entire length of this, we can simply say 2 times x plus 7. So that's going to determine, and that's going to find dB. Now what do we know about dB? We know that it equals AC. So it equals AC, and we know what AC is. 4x minus 13. Alright, so now let's look to solve. 2x plus 14 equals 4x minus 13. For simplicity reasons, let's go ahead and subtract a 2x here, and let's add a 13 plus a 13 minus a 2x. I'm doing these two steps in one foul swoop. 27 equals 2x. Divide both sides by 2. You will be left with an x equals 13.5. We want to find the value of x, therefore we are done. Alright, now let's look to our final page of notes. We're looking at example 4. It says use the rectangle KLMN and the given information to find the following. It wants us to find the measures of angle 2 through 6 and 8 through 10. Alright, so let's just begin where we can. I immediately see we have, it's kind of interesting to see what we've got here in terms of our angles and our degrees. Okay, so it gives us the measure of angle 1. We have a 70, and it gives us 7. This is all that it gives us, 20. Alright, knowing that these are, find a little different color here, knowing that these rectangles, we know what? That all of these angles up here, all of them, every one of them, will add up to 90 degrees. So we can find 8 pretty quickly. 8, 90 minus 20, 70. So 8, I'm going to go over here, I'm going to put 70 degrees. Alright, now, I'm trying to see here, we've got C, let's see, that's just our point. I'm going to go ahead and I'm going to fill out just about everything. We have a triangle here. We have 70, 70. What's our third angle? 70, 70, that's 140. 180 minus 140, that's 40. These are on a straight line. These are a linear pair. Together, they add up to 180. So, what plus 40 equals 180? 140. We also know that these are a bow tie or vertical angle, so they are congruent. We've got another 140 and another 140. Now up here we've got to get 90 out of these two. So there's our 20. Now, just as I said before, imagine here, this is our transversal cutting our two parallel lines in half. We have right here alternate interior angles. What do? Well, they are congruent. I don't need a 1 over here. It should just be a 40. So, that's congruent. Here will be congruent. We can just go filling stuff in now. These are also congruent because they are, once again, if this is the transversal cutting right here, here's our parallel lines. These are alternate interiors. And the same can be said over here. Measure of angle 2, 20 degrees. The measure of angle 3, 20 degrees. Measure of angle 4, 70 degrees. Measure of angle 5. We can go through and we can just rattle off everything right here. We've got everything solved. All we have to do is look over and find the correct numbers. Alright, let's scroll on down to our last example, example 5. Quadrilateral RSTU is a rectangle. If the measure of angle RSU, okay, let's see here, let me grab a color. RSU, okay, so we're coming back, is a 3x minus 5. Measure of angle UST is 4x plus 4. Find the value of x. What do we know? I did this in the last one. What do we know about this angle up here? If it's a rectangle, it's a right angle. That means it equals 90. So we have two things when added together equal 90. Two things when added together. 3x minus 5 plus, I'm adding them together, 4x plus 4 equals 90. Equals 90. That's what I said. I just wrote it out. 3x minus 5 plus 4x plus 4 equals 90. Alright, 7x minus 1 equals 90. Plus 1, 7x was 91. Ooh, wow. I don't need to get that carried away. Divide those by 7s. Make sure my 7s are pretty clear here. Divide by a 7. X equals 13. What are we after? Find the value of x. Problem solved.